There we go. Okay, so we are going to be starting right inside here. We're going to look at these ones today up to this polka dot one, but we're just going to skip a couple of lines that we'll talk about on Monday. So we're going to start by talking about domain and range, and we're going to talk about things that are functions versus not functions, and all that jazz. So they should hopefully be words you've heard before. It's been a minute, but we may have heard them. Does anyone remember what domain talked about? What was that? Remember? It's been a while. I get it if we don't. So domain, what that talks about is our input into some sort of relationship. More often than not, and I would say 99.999% of the time, this is the x values. The x values of an equation, relationship, graph, whatever it is that we're talking about. So I'm going to put all that part on there. And equation, graph, or relationship, because sometimes it's not purely an equation. When I'm writing on the screen, if I ever pick a color that you cannot read, I write too small for you to see in the back, or I go too fast, please, please, please let me know. Please, please, please. 100%, no shame in that. I get excited about math, and sometimes I go fast. And I can barely see the screen from this angle, so if it's not showing up, I will have very little idea. Okay, so just let me know. So our domain is all about the input. So it's the x, usually it's something we substitute in. It can be a number we plug in, all that stuff. All those things. It could be a button. So like the relationship stuff, my kind of favorite example of this is a vending machine. If I hit the button for Mountain Dew, I expect a Mountain Dew to come out. So my input is hitting the Mountain Dew button. What comes out, the output, the can that comes out, that's my Mountain Dew. That is what we usually call our range and our y values. So our range is going to be the output, what we get out of an equation. And again, more often than not, it's the y values. Very little space there. Of an equation, graph, or relationship. I'm going to write them all again, but you don't have to. So the can of soda that comes out of my vending machine, that would be my output. Hit the Mountain Dew button and I get a can of soda. I hit an input, I got an output. The relationship between what those two values are is what we're talking about when we're talking about function and one-to-one function. So what a function means, easy way to kind of remember that is to think about if the vending machine is functioning, when I hit Mountain Dew, I get a Mountain Dew. If I hit Mountain Dew and I get a Coke, not functioning correctly. If the input I get is different every time or than we expect, it's not functioning correctly. So what it means for something to be a function, mathematically, what this is going to be is that each input, each x value, each button I press on the machine is going to give me one answer. So if I hit Mountain Dew, I get a Mountain Dew. If I hit Coke, I get a Coke. If I hit Sprite, I get a Sprite. If I hit Mountain Dew and I get a Fanta, and then a Sprite, and then a Coke, we are chaos. I mean, there's some machines that'll do random, but still. So a function means that each input, so no matter which button I press, it's only going to give me one output. So each x gives me only one y. I can't substitute 2 into an equation and get both 7 and 12. Like, I can't get more than one answer for each x. And the way that we're going to test this when we start looking at pictures and stuff is we're going to use something called the vertical line test. So I'm going to put that here, and I will show you when we get to the graph what that's going to be. So this is how we test for this. We're going to test using the vertical line test, which you can, VLT is totally fine. I just was giving you all the words. So something can be a function or not a function at all. So if it's passing our vertical line test, it's going to be a function. For something to be a one-to-one function, it has to first be a function. So a one-to-one function is a special kind of function. So if a function means each input gives us only one output, then what a one-to-one function is the reverse of it. Each output comes from only one input. The only way I can get a Mountain Dew is if I hit the Mountain Dew button. The only way I can get a Coke is if I hit the Coke button. If I can get a Mountain Dew by hitting the Coke button, we are definitely not one-to-one. Or if I have 2 Mountain Dew buttons, because sometimes they'll do that like with Coke or Pepsi, because a lot of people like cola, but like if there's 2 ways that I can get Coke or Pepsi or whatever, it's not one-to-one because I have 2 different options to get that same output. So for a one-to-one function, each output, or y, comes from only one input. Okay, my decorative background is in the way. Each x comes from only one y. So the only way to get a Mountain Dew is to hit a Mountain Dew button. The only way to get a Coke is to hit the Coke button. There's no randomization option. And again, we have a test for this, which again, I will show you. And when we look at our graphs here, it's going to be that. So if we're testing our functions with our vertical line test, the way we're going to test for our one-to-one function is going to be kind of the switch from vertical, which is going to be our horizontal. I never remember how to spell horizontal. Luckily, it's on the wall. So we're going to use the horizontal line test. If I ever spell something wrong up on the board, tell me, I will believe you. I am trash at spelling. Grammar is a construct and spelling is a suggestion. If it's close enough for autocorrect, it's close enough for me. I have been known to spell something so badly that even Google doesn't know what I want. I sometimes have to turn on voice to text to be able to say the word I mean because I'm that bad at spelling. That's why I'm not an English teacher. Okay, so these are going to be like our vocab words for today, and honestly, I think for most of Monday. We'll have a little bit on Monday, but these are going to be what we're focusing on here for this first kind of bit. And I know sometimes when we write down these definitions, we go, I just wrote words that I have no clue. And that's okay, because we're going to work through some examples with it, and that'll kind of help. So when we're looking at things like domain and range, we're looking at just our x values and just our y values. When we're looking at our function versus our one-to-one, we're looking at how they're relating to each other. So when we're writing things like domain and range, we're going to have a couple of different options. I'm only going to show you one of those options today, and I'll show you the other option on Monday. And so I'm going to put something up here that's not in your packet, but it's like not super long, and it is super review from Algebra 1. You'd be able to fit it up on this top if you really want to have it. So I'm going to put 2 little number lines up here because we're going to use some inequalities to write these. And I know it's been at least a couple of months since we thought about inequalities. At least. Valid. So let's just think about these for a second. What do we notice about these 2 things I have up here on number lines? What do we notice about these here? Yep, theirs are going in opposite directions. Absolutely valid. 100%. What else do we see? One's open and one's closed. I don't remember what that means. No, it's a valid option. Like, you're allowed to say no, I don't remember. Like, totally fine. It's been a minute. So if we have something that's colored in, because I can usually, like, I can land on this line here. If whatever this is, if I can have 2 or that away, I could have 4, I could have 10, I could have 500. I can have 2. It's colored in. It's valid. I can stand on this line. Right there. I'm on it. If it's an open circle, what this tells me is there's a lava pit on 2. I can get close to it. I could be on this side of it. These are smaller numbers, but our number line. So I could be at -1. I could be at 0. I could be at -500. I could be at 1.999999999. I just can't be on 2. It's a lava pit. I have to jump over it. So when we have open circles, that's when it's going to be either our less than or greater than. So if this was something like x's, what we're going to do is we're going to write this as our x has to be, and in this case, since we're looking at that left, has to be smaller than 2. On this pink one, our arrows point in the other direction. So whatever this value is, our x would need to be bigger than 2. Greater than or equals to, because it's closed in. So closed circles get the equals to, open circles do not. And as far as the less than, greater than part of it, think about the crocodile. Taught us that in like 2nd, 3rd grade. I have a friend who's a literal rocket scientist. She works at Rolls-Royce in the aerospace engineering department, like literal rocket scientist. And I asked her one day, I'm like, do you ever think about the alligator when you're doing inequalities? She went, every single time. Just because we learn it in 1st, 2nd, 3rd grade does not mean it's not a valid tool. She's a literal rocket scientist and still thinks about the alligator eating the bigger number. Okay? So, if that helps, alligator goes that way. Okay? So, this right here, these 2 pieces with our inequalities, that's what we're going to use for what we call our algebraic notation. On Monday, I'm going to show you something called interval notation that we'll use a lot as we, this semester. And so since we're going to use it a bunch, I wanted it right next to it. We're going to practice it, practice it, practice it. Okay. So we're going to start with our algebraic notation. So we're going to look at these 3 examples that we have here, and we're going to write our domain and our range, and we're going to test to see if they are functions or not functions. So we're going to start by looking at this guy here. These graphs are all supposed to have arrows on them, but there was a formatting issue, so they are all supposed to have arrows at the top. So let's take a look at this one. And I actually want us to think about our domain here. What x values will work on this? What x values can we use? When we are thinking domain and range, sometimes it helps for some people to think about if I smash this flat onto the x-axis. So if I took this whole thing and I was like, I don't care how hot up it goes, how high down, how low down it goes. I'm going to smush it. What x's can I use? Well, I can use 0. I've got a point here. I can use 1. I've got a point. I can use all the stuff in between. I can use 2. I can use 3. I can use 4. It's going to be way up there. I can keep going. I can go up to the ceiling. I can go into space. Be cool. So this, I can use absolutely any x value I can think of in the entire existence of the world. I can go big. I could go negative. I could go small. Because this continues outwards. I could take this parabola and I could make it go, and it would go the whole way across. So we could use any number in the entire existence of the universe. So we have a couple of special ways of writing that. If I can use any number in the entire universe, that means I could use all real numbers. Long way of writing. All real numbers. There is a shortcut way of writing that. And it's a capital R with an extra stick. I'm going to write again. It's a capital R like this, and then you put an extra vertical piece right inside. So that means all real numbers. That's anything I can point to on the number line at all in the entire universe. I can point to 10, I can point to 5 million. I can point to 3.11, 3.5. I'm going to 1/3. They're all there. So all real numbers is a possible option. And that's our domain on this one. So I can use any x in the universe I can think of. There's nothing holding me back from picking an x. Our range is all about where those x's land. So if I have my x of 1, I get my y value down here at like -2 with some change. If I have my x value 2, I land right here at 0. If I have x of 3, I land up here at about 3.5. I am getting these values from what my y values are. So what is the very, 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 very smallest y value I will ever get on this one? What is the very, very smallest y value? How low can it go?
-3.
-3. Will I ever get a y value of -4? I got no dot down here. Nowhere is going to reach -4. I cannot reach -10. I cannot reach -100. The very, very lowest this is going to go is -3. So my y's have to be -3 or bigger. So the way we can write our range on this is that my y's need to be bigger than or equal to -3. Because the very, very smallest our y's can go is right down here. I cannot go further down. Questions on our domain and range on this one? Okay. Let's try our function test, because, we haven't done that yet. When we were talking about our function, that was in our each input, so every number that we pick goes to only one output. So each x goes to only one y. Each x goes to only one y. Each x goes to only one y. We call it the vertical line test because what I'm doing is I'm seeing if each of these only goes to one y. So what we're going to do is we're going to take a vertical line, super duper high-tech fancy schmancy math tool, a stick. Any stick will do. Pencil, ruler, edge of calculator, post-it note, any stick will do. And I want to say, does it ever cross my line more than one time? So if I take my vertical line, we hold it vertical, and I run it across my table, or my graph. Does it ever cross this red line more than one time? Does it ever cross the red line more than once? It follows it, so like, here's where it's crossing here, here, and then it goes back up. But it never crosses more than once. So that means it passes the vertical line test. That's how we're checking. So that means that this is a function. It passes that vertical line test. Sorry, I will rewrite that because that was... We used the vertical line test for this, and it passed. So yes, it is a function. For our one-to-one test, that's when we're going to look at our horizontal line test, which is, again, very, very similar. So if this was vertical line test, horizontal line test goes, boop, sideways. Same test. I'm going to run it along my graph, and we're going to see, does it ever cross more than once? Does this ever cross my red line more than one time? What do you think? Is it crossing more than once?
Yes.
Yeah, here and here. Up here it crosses here and here. Down here it's crossing here and here. So this crosses more than once, lots of places. It only takes one failure for us to say no. Think of it like if I had a bug in my food, it only takes one for me to say, I am not eating this food, thank you very much, and the whole plate is gone. Thank you. So our horizontal line test failed. So this is not a one-to-one function. If it ever crosses more than one time, no go. Ever. Okay, we're going to practice these both again a couple more times. But questions on those ones? Okay. On Monday, we will come back and do the interval notation bits. Just because, again, we're going to use those a lot throughout the year, and I want to practice those when we're going to have time to practice for a couple of days. So let's try on the next one. So it looks like this. And it's got a weird in it. Because we looked at the open circles a little bit when we looked at those inequalities on the number line. But what those are, when we have something like this thing, right here in the middle, at the -2, just like with the open circle on our number line, I think of these as lava pits. I can follow along this road, wiggle, 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 but I've got to jump over that hole. That tells me somebody stabbed a hole in the line, and I have to jump over it. So what that means when we're looking at something like domain and range is wherever I have somebody stabbing something, I've got to avoid it. So for the most part, if we ignored this little line here, what would our domain be if it looked just like this? Without this little hole here. What do you think? If we did not have this little dot, what would our domain be? What do you think? Is there any x we cannot use if I have this covered up? Or any place we won't wind up? Because I could go farther and farther negative. It's continuing off over here. This line continues up. Got an arrow. So I can keep going up and up and up and up and up and up and up. So it's going out too. So I can keep going forever and ever and ever. I can use my x of 0. I can use my x of -3. I can use -100. I could go bigger on my x's. This line's continuing down, but that means it's also going out. So I could use 1, 2, 3, 4, 7, 12, 500, 4,547,432. I can use whatever number I want. So I can use absolutely any number in the whole universe except the one piece I have to jump over. The one thing my x's cannot be is -2. I have to jump this lava pit. Somebody stabbed a hole in the road. I got to jump over it. It's a pothole. Don't go through it. You'll bust your axle. So my domain can be anything except -2. So we have a couple of ways we can write this. I can put that x cannot equal -2. That is one way of writing it. That tells me that it is all real numbers, so fancy schmancy R, except for -2. Anything but -2. Or I could do it as two inequalities, that my x's either need to be less than -2 or they need to be bigger than -2. They just can't equal it. So we can write it like this. X is less than -2 or x is greater than -2. Both ways are totally fine and they mean the same thing. This means everything except -2. This is all the numbers smaller than -2 and all the numbers bigger than -2, which is just whether we're saying it as a positive or as a kick him out. Saying y'all can come and y'all can come, but I'm just not addressing you. Versus everybody's welcome except you. So it's just two different ways of wording it. And I genuinely do not care which way we word it. Our range on this one is not near so complicated. Because our range, that's our y values. When I use those x's, everything except -2, where do we land? Well, these x's are going to keep going down and down and down. So my y's are going to get real, real low. They go real, real low, as far down as I can imagine. So there's nothing stopping them from getting low. I've got this big old arrow up here saying it's going up, so those are getting big, for sure. My y's are getting big way up here. So we really just got to make sure each y value has a value. And even though we have this hole here, I have something else that gives me a value at 0. I have places where it exists here. So our range, that hole doesn't really matter. Because if I was to take this and squish it into my just y's, everything's covered. Every output has at least one input that'll give me that answer. Every single one I can imagine. I could figure out what x would give me an answer of 2. I could figure out what x would give me an answer of -1. I could figure out what x would give me an answer at 0. An x of 0 and an x of 2 would both give me an answer at 0. So I can get every possible number I can imagine. So our range on this guy is going to be exactly the same as what it was on the other one. So our range, or it's going to be what the domain was on the other one, is going to be our all real numbers. Everything in the entire existence of the universe, I can get my y values to be. Cool, we're on time. Then let's do our function test. Function, vertical line test. I'm going to grab our stick, fancy schmancy, super duper high tech math tool. Functions, we're going to do our vertical line test. And I want to know, does this ever cross more than one time? Let's slide this across my graph. Does my vertical line ever cross my red line here more than once? Does it ever cross more than once? A vertical line test still passes. So this is a function. More often than not, we are going to have functions. It's going to be occasional that we don't. So if you are getting not a function every single time, double check with me. More often than not, things you're going to deal with are going to be functions, just because that's what Algebra 2 is all about, is functions. So we'll have a little bit in this chapter that might not be functions, but most things we deal with will be. One-to-one functions, no guarantees there. So we did our vertical line test for our function. For our one-to-one, we do our horizontal line test. Does this ever cross more than one time? What do we think? Is this going to pass or is this going to fail? Does it ever cross more than one time? Mm-hmm. It passes up here, cool. Passes down here, awesome. It fails right here in the middle. It's crossing 3 times right here. That's a lot. It only takes one fail for us to go, no, not happening. So our horizontal line test, that one fails. So it is not a one-to-one function. It only takes one failure for us to say no. I don't care if it only crosses twice, one time. Like, I don't care. It just takes one. Again, I think of it as hair in your food. It only takes one. Okay. We're going to look at one more graph, and then we'll be done. It looks like a scatter plot. So it looks like this. We got little dots and dots and dots. And remember that our domain, those are our x's, and those are our inputs. So when we're trying to figure out what our domain is on something like this, and I don't have like a line that's all connected up, I just have these guys. I just have whatever my x values are for these points. So each of these points has like an address, if you think about it, old school algebra vibes, like Algebra 1. When we would plot up these points, when they would have like their addresses at 1, 1, these things, x, y, and we have our 2, 3, those pieces. When we're looking at our domain, we're We're literally just looking at our x values. So if it helps you, you can come through and label these points. This one's between 1 and 2, so probably about 1.5, comma 0. You can label them that way, or you can just kind of look at it. Sometimes I'll just grab a ruler and I'll just like kind of trace them, because I can. Because what we're gonna do for our domain and range is we're just gonna write out the points and list them. Kind of math grammar says we go from smallest to biggest. It's kind of like the math version of alphabetical order is smallest to biggest. It's not something I'm going to be petty about. It just kind of makes my brain itch if we don't do it that way. But it's not wrong to put them in whatever order we see. So what we're going to do for our domain is we're just straight up going to write out what x values there are. So I'm going to start with the smallest, which is this guy over here. So this is my smallest x, which is -3. So our domain, whoa, chunky pen. Try that again. Wah! Oh, my iPad's frozen. Love that so much. There we go. Yay, we're back. No! Oh my gosh, computer. No, there is not another instance of this program running in a different tab. So we're going to make a list of those points. So we're going to have our -3. You guys can see your pictures of our -2. Oh my gosh, computer. Then we're going to have our -1 and our 0 and our 1 and our 1.5. And I'm going to drop kick my computer. So we just make a list. See which one's first, old school or new school. There we go. So our -3, our -2. -1, 0, 1. Between 1 and 2, it's probably about 1.5 or 1.5. Does not matter if you do decimals or fractions, and then 2. So we just make a list. Same thing for our range. We're just going to make a list of our y values. So domain is everything to do with our x's. Range has everything to do with our y's. So again, we just make a list. And again, I tend to go smallest to largest. It's kind of math grammar, good way to write things. But we're going to go -1 is my smallest one. And then our negative about 1/2. Maybe it's 0.5, maybe it's 1/2. Who knows? Our next y value is 0. And then our next y value is 1, 1.5, not 2. We have 3, and we have 4. So those are our domain and range pieces there. We will do our function test on this one on Monday. I'm going to put it over here by the notes packet. The first homework that we have for this chapter is not going to be due until Wednesday, so if you don't want it, that's okay. But I'm going to put it over here right by the notes packet for you guys to pick up, just because we have nothing to spell. This technology is awesome. But that way you can have it in case things go wonky again. It has on there things we're still going to talk about next week. So we're going to look at our interval notation. We'll do the rest of our function test. And we'll finish some stuff out before that's due. So there's going to be words on there that we're not as familiar with. But we'll talk about them next week. Okay? So that gives you a start. That lets you look at it. And you can do some of the things on that page. Feel free to pick that up. Otherwise, I will pass it out to you guys on Monday.